The universe is unimaginably vast, a sprawling expanse of galaxies, stars, and cosmic mysteries. Yet, despite our best efforts, less than 1% of all galaxies have been mapped. That means we've barely scratched the surface of understanding the cosmos. What if I told you there's a way to explore these distant realms without the need for human intervention? Enter autonomous spacecraft, cutting-edge technology that could revolutionize how we uncover the secrets of the universe. These self-navigating marvels have the potential to map galaxies millions of light years away, pushing the boundaries of our knowledge further than ever before. But how do they work? What challenges do they face? And what could this mean for the future of space exploration? In this video, we'll dive into the fascinating world of autonomous spacecraft, exploring the technology behind them, the hurdles they must overcome, and the extraordinary possibilities they hold for mapping the galaxies we've only dreamed of reaching. Let's embark on this journey together and discover how the stars might finally be within our grasp. The story of space exploration is as much about human ingenuity as it is about the relentless pursuit of the unknown. It began centuries ago with the invention of the telescope, a simple yet revolutionary tool that allowed us to peer beyond our planet for the first time. Galileo's observations of Jupiter's moons in the early 1600s shattered the notion that Earth was the center of the universe, sparking a curiosity that would drive humanity to reach further into the cosmos. Fast forward to the mid-20th century, and we see the dawn of the space-age rockets breaking free from Earth's gravity, satellites orbiting our planet, and humans setting foot on the moon. These were monumental achievements, but they came with significant limitations. Human-led missions, while awe-inspiring, were constrained by the vast distances of space, the sheer amount of time required to travel, and the enormous resources needed to keep astronauts alive and equipment functional. As we pushed further into the solar system, we began to rely more on robotic explorers. Probes like Voyager, which ventured into interstellar space, and the Hubble Space Telescope, which revealed breathtaking images of distant galaxies, demonstrated that machines could go where humans could not. These missions were groundbreaking, but they still required constant communication with Earth, creating delays and limiting their scope. The Mars rovers like Spirit, Opportunity, and Curiosity marked a turning point. These robotic explorers could make decisions on their own, navigating the Martian terrain and conducting experiments without waiting for instructions from Earth. They were the first steps toward true autonomy in space exploration. This shift toward autonomy wasn't just a technological leap, it was a necessity. The farther we go, the longer it takes for signals to travel between Earth and our spacecraft. Imagine trying to control a probe near Pluto, where a single command could take hours to arrive. By the time the probe responds, the situation on the ground might have changed entirely. Autonomous systems capable of making real-time decisions solve this problem. They can adapt to unexpected challenges, prioritize tasks, and even identify scientific opportunities without human intervention. These capabilities are essential for exploring the outer reaches of our solar system and beyond. The journey from Galileo's telescope to autonomous Mars rovers has been one of constant evolution, driven by the need to overcome the limits of human-led missions. Now, as we look to the stars and dream of mapping new galaxies, autonomy is no longer just an option. It's the next logical step. The groundwork has been laid, and the possibilities are as vast as the universe itself. Autonomous spacecraft are the next leap in space exploration, designed to operate independently, far beyond the reach of human control. Unlike traditional missions, where every move is carefully planned and executed by teams on Earth, these spacecraft rely on artificial intelligence, machine learning, and advanced algorithms to make decisions in real time. Imagine a spacecraft not just following a pre-programmed path, but adapting to unexpected challenges, analyzing data on the fly, and choosing the best course of action, all on its own. This level of autonomy is what sets these missions apart, allowing them to explore deeper into space with greater efficiency and precision. At the heart of this technology is artificial intelligence, which enables the spacecraft to process vast amounts of data and learn from its environment. Machine learning algorithms allow these systems to recognize patterns, predict outcomes, and make informed decisions without human intervention. For example, NASA Perseverance rover uses autonomous navigation to traverse the rocky terrain of Mars, avoiding obstacles and selecting the safest path. It's not just about moving from point A to point B. It's about making smart, calculated decisions that maximize scientific discovery. But what makes this technology truly revolutionary is its scalability. While current autonomous systems like Perseverance are limited to planetary exploration, the same principles can be extended to intergalactic missions. Imagine a spacecraft traveling to a distant galaxy, light years away from Earth. Communication delays would make real-time control impossible, so the spacecraft would need to rely entirely on its own intelligence. It would map uncharted regions, identify points of interest, and even decide where to collect samples, all while navigating the vast, unpredictable expanse of space. To achieve this, autonomous spacecraft will need to be equipped with specific capabilities. They'll require advanced sensors to gather detailed information about their surroundings, robust computing power to process that data, and sophisticated algorithms to interpret it. These technologies will allow them to create high-resolution maps of galaxies, pinpointing stars, planets, and other celestial objects with remarkable accuracy. The ability to operate independently in such extreme environments will open up new frontiers in our understanding of the universe, making the dream of intergalactic exploration a reality. At the heart of every autonomous spacecraft lies a symphony of cutting-edge technologies, each playing a crucial role in ensuring these marvels can navigate, survive, and thrive in the unforgiving void of space. One of the most groundbreaking advancements is AI-driven navigation. Unlike traditional systems that rely on pre-programmed instructions, these spacecraft use artificial intelligence to make decisions on the fly. Imagine a ship that can analyze its surroundings, detect obstacles, and chart the safest course through asteroid fields or around gravitational anomalies, all without human intervention. This level of autonomy is made possible by machine learning algorithms that continuously improve as they process more data, adapting to the unpredictable challenges of space. But what happens when something goes wrong millions of miles from Earth? That's where self-repairing systems come into play. These spacecraft are equipped with materials and mechanisms that can detect damage, like micrometeoroid impacts or radiation-induced faults, and initiate repairs autonomously. Think of it as a spacecraft with its own immune system, capable of healing itself and ensuring mission continuity even in the harshest conditions. This technology not only extends the lifespan of the spacecraft, but also reduces the need for risky and costly human intervention. Of course, to travel the vast distances required for galactic exploration, advanced propulsion methods are essential. Traditional chemical rockets are no longer sufficient for these ambitious missions. Instead, scientists are turning to innovations like ion drives and nuclear propulsion, which offer far greater efficiency and speed. Ion drives, for example, use electrically charged particles to generate thrust, allowing spacecraft to accelerate gradually over long periods, reaching incredible velocities. Nuclear propulsion, on the other hand, harnesses the immense energy of nuclear reactions to propel spacecraft at unprecedented speeds, potentially cutting travel time to distant stars by decades. None of these technologies would be effective, however, without the ability to process and communicate data in real time. Spacecraft must analyze vast amounts of information, from sensor readings to environmental data, and make split-second decisions. This is where quantum computing comes into the picture. Unlike classical computers, which process information in binary bits, quantum computers use qubits, allowing them to perform complex calculations at lightning speed. This capability is a game-changer for autonomous spacecraft, enabling them to handle the immense computational demands of navigating uncharted regions of space. Equally important are deep space communication networks. These systems allow spacecraft to stay connected with Earth, transmitting data and receiving updates even across billions of miles. Innovations like laser-based communication are revolutionizing this field, offering faster data transfer rates and greater reliability compared to traditional radio waves. These networks ensure that, even as spacecraft venture farther into the cosmos, they remain part of an interconnected system that supports their missions. When you combine these technologies, AI navigation, self-repairing systems, advanced propulsion, quantum computing, and deep space communication, you get a spacecraft that's not just a machine, but a highly intelligent, resilient explorer. These systems work in harmony to overcome the challenges of space, from the intense radiation of distant stars to the gravitational pull of black holes. Together, they form the backbone of autonomous spacecraft, paving the way for humanity's next great leap, mapping the galaxies beyond our own. Yet, as remarkable as these technologies are, the task of mapping new galaxies presents its own set of challenges. The sheer scale of the universe, the incomprehensible distances between stars, and the mysteries of dark matter and dark energy all stand as formidable obstacles. But with the tools we've developed, the dream of charting the cosmos is no longer just science fiction, it's a mission within our grasp. Mapping galaxies is no small feat, especially when you consider the sheer scale of the universe and the obstacles that stand in the way. Autonomous spacecraft, despite their advanced technology, face a series of daunting challenges that make this task incredibly complex. First, there's the issue of distance. Galaxies are separated by unimaginable stretches of space, millions or even billions of light-years apart. Even with the fastest propulsion systems we have today, traveling between galaxies would take thousands of years, if not more. And that's just to reach the closest ones. Then there's the problem of cosmic radiation. In the void of deep space, spacecraft are bombarded by high-energy particles that can damage sensitive instruments and disrupt communication systems. Unlike Earth, which is shielded by its magnetic field, there's no protection out there. This radiation poses a constant threat to both the spacecraft and the data it collects, making long-term missions a risky endeavor. Another major hurdle is the lack of reference points. In our solar system, we can use the sun, planets, and stars to navigate, but in the vast emptiness between galaxies, there are no such landmarks. Spacecraft would need to rely entirely on advanced sensors and algorithms to chart their course, which adds another layer of complexity to the mission. Current propulsion systems also present a significant limitation. Chemical rockets, the engines we've relied on for decades, are simply not efficient enough for interstellar travel. They burn through fuel too quickly and lack the sustained power needed to cover such immense distances. What we need are energy-efficient systems that can operate for years, if not centuries, without refueling. This has led researchers to explore alternatives like ion drives, nuclear propulsion, and even theoretical concepts like light sails. But even if we solve the propulsion problem, there's still the challenge of power. Spacecraft need a reliable source of energy to operate their instruments, transmit data, and maintain their systems. Solar panels work well close to stars, but in the darkness of deep space, they're practically useless. This has driven the search for long-lasting power sources, such as advanced nuclear batteries or even harvesting energy from cosmic phenomena. And then there's the issue of communication. Transmitting data across interstellar distances is a monumental task. The farther a spacecraft travels, the weaker its signal becomes, making it harder to send information back to Earth. Even with powerful antennas, the delay in communication could stretch to years, depending on the distance. This not only complicates mission control, but also limits how much data we can realistically receive. Despite these challenges, scientists and engineers are working tirelessly to overcome them. From developing more durable materials to withstand radiation to experimenting with new propulsion technologies, the push to map new galaxies is driving innovation at an unprecedented pace. The dream of exploring the cosmos may still be in its early stages, but with each breakthrough, we're inching closer to making it a reality. The vastness of space presents one of the greatest challenges for interstellar exploration: distance and time. Even with our fastest propulsion systems, reaching another galaxy could take millions of years. But what if we could bend the rules of physics as we know them? Enter concepts like warp drives, solar sails, and ion propulsion technologies that could revolutionize how we think about crossing the cosmos. Warp drives, inspired by theoretical physics, suggest a way to warp space-time itself, effectively shortening the distance between 2 points. Imagine folding a piece of paper so that 2 distant dots touch. That's the essence of a warp drive. While still in the realm of theory, advancements like the Alcubierre drive propose a way to achieve this by creating a bubble of distorted space-time around a spacecraft. It's a tantalizing idea, but one that hinges on harnessing exotic forms of energy we don't yet fully understand. On the more practical side, solar sails and ion propulsion offer promising alternatives. Solar sails use the pressure of light from stars to propel a spacecraft, much like a sailboat catching the wind. Ion propulsion, on the other hand, relies on electrically charged particles to generate thrust. While these methods are slower than warp drives, they're already being tested in real-world missions, proving that incremental progress is possible. Then there's the mind-bending concept of wormholes, hypothetical tunnels through space-time that could connect distant parts of the universe. If they exist, traversing them could reduce travel time from millennia to mere moments. But like warp drives, wormholes remain theoretical, requiring breakthroughs in physics and engineering to become viable. What ties all these ideas together is the role of artificial intelligence. AI could optimize travel routes, calculate the most efficient use of energy, and even make real-time adjustments during a mission. For instance, an AI-powered spacecraft could analyze cosmic phenomena like gravitational fields or radiation levels to plot the safest and fastest path through the stars. It's not just about getting there, it's about getting there smartly. As we push the boundaries of what's possible, one thing becomes clear. Overcoming the challenges of distance and time will require a blend of bold, theoretical thinking and practical innovation. And at the heart of it all, AI, quietly working behind the scenes to turn these visionary ideas into reality. Imagine being able to send a spacecraft on a journey billions of miles away, knowing it can think for itself, adapt to the unknown, and even learn as it goes. That's the power of artificial intelligence in autonomous spacecraft. Unlike traditional missions, where every move is meticulously planned and controlled from Earth, AI gives these spacecraft the ability to navigate, make real-time decisions, and tackle challenges on their own. It's like giving them a brain, a sophisticated one that can process, analyze, and act in ways that were once the stuff of science fiction. At the heart of this capability are machine learning algorithms. These algorithms allow spacecraft to learn from their environment, improving their performance over time. For instance, if a spacecraft encounters a new type of cosmic debris or an unexpected gravitational pull, its AI system can analyze the situation, adjust its course, and even store that information for future use. This adaptability is crucial when exploring regions of space where communication delays make real-time control from Earth impossible. By the time a signal reaches us, the spacecraft might already be in a completely different situation, so it needs to think on its own. But AI's role goes beyond just navigation. One of its most critical functions is data processing. Spacecraft exploring distant galaxies gather staggering amounts of information, images, radiation levels, atmospheric compositions, and more. Without AI, sifting through this data would take years, if not decades. Machine learning algorithms, however, can analyze this information in real time, identifying patterns and anomalies that might otherwise go unnoticed. This not only speeds up discovery, but also allows scientists to focus on the most promising findings. Take, for example, the Mars rovers. These robotic explorers rely heavily on AI to navigate the red planet's rugged terrain, avoid obstacles, and decide where to collect samples. Similarly, the James Webb Space Telescope uses AI to optimize its observations, ensuring it captures the clearest images of galaxies billions of light years away. These are just a few examples of how AI is already revolutionizing space exploration. Now, think about what this means for mapping new galaxies. AI could enable spacecraft to autonomously chart star systems, identify habitable planets, and even predict cosmic events like supernova. By processing data on the fly, these intelligent systems could create detailed, dynamic maps of the universe, updating them as new discoveries are made. This isn't just about exploration, it's about expanding our understanding of the cosmos in ways we've never thought possible. As we look to the future, the synergy between AI and space exploration promises to unlock mysteries that have baffled humanity for centuries. From navigating the unknown to processing the unimaginable, artificial intelligence is proving to be the ultimate co-pilot in our journey through the stars. So, how exactly would an autonomous spacecraft go about mapping something as vast and complex as a galaxy? The answer lies in a combination of cutting-edge technologies, each designed to capture a different piece of the cosmic puzzle. One of the most powerful tools in its arsenal is high-resolution imaging. By using advanced cameras and sensors, these spacecraft can capture incredibly detailed images of distant galaxies. These images don't just show us what a galaxy looks like, they reveal the intricate structure of its stars, dust clouds, and even the faintest traces of light from ancient events. It's like having a cosmic microscope, allowing us to zoom in on the fine details of the universe. But imaging alone isn't enough to tell the full story. That's where spectroscopy comes in. By analyzing the light from distant stars and galaxies, spectroscopy can determine their chemical composition, temperature, and even their movement through space. Think of it as reading a galaxy's fingerprint. Every element leaves a unique mark in the light spectrum, giving us clues about how these galaxies formed and evolved over billions of years. This technique has already been used in missions like the Hubble Space Telescope to study nearby galaxies. But imagine what an autonomous spacecraft, equipped with even more advanced sensors, could uncover in uncharted regions of the cosmos. And then there's gravitational wave detection, a relatively new but groundbreaking method. Gravitational waves are ripples in the fabric of space-time caused by massive events like colliding black holes or neutron stars. By detecting these waves, autonomous spacecraft could map the locations of these cataclysmic events and even trace the distribution of dark matter, a mysterious substance that makes up most of the universe's mass but remains invisible to traditional observation methods. It's like listening to the universe's heartbeat, revealing hidden structures and phenomena that we've never been able to see before. Of course, collecting all this data is only half the battle. The real challenge lies in making sense of it. That's where artificial intelligence steps in. AI algorithms can process vast amounts of data far faster than any human team, identifying patterns and anomalies that might otherwise go unnoticed. For example, AI has already been used in smaller-scale missions to classify stars, predict cosmic events, and even identify potential exoplanets. In the context of galactic mapping, AI could help us piece together the complex relationships between stars, gas clouds, and dark matter, painting a clearer picture of how galaxies function. What's truly exciting is what this combination of technologies could reveal. For the first time, we might uncover the secrets of galactic formation, understand the role of supermassive black holes in shaping the cosmos, or even detect signs of life in distant star systems. Every new map created by these autonomous spacecraft could bring us closer to answering some of humanity's biggest questions. And who knows, the next discovery might just rewrite everything we thought we knew about the universe. Mapping new galaxies isn't just about charting the stars, it's about unlocking the deepest mysteries of the cosmos. Imagine uncovering clues about dark matter and dark energy, two of the most elusive forces in the universe. These invisible phenomena make up more than 95% of the universe's total mass and energy, yet we barely understand them. By analyzing the distribution and movement of galaxies, autonomous spacecraft could provide the data needed to solve these puzzles, shedding light on how the universe expands and evolves. This isn't just science fiction, it's a tangible step toward answering questions that have baffled humanity for centuries. But the discoveries don't stop there. Mapping new galaxies could also reveal planetary systems beyond our wildest imaginations. Think about it, every star we observe could host planets, some of which might lie within their star's habitable zone, a region where liquid water could exist. These worlds might not only resemble Earth but could also harbor the building blocks of life. Autonomous spacecraft equipped with advanced sensors could scan these distant planets for biosignatures like oxygen or methane, hinting at the possibility of extraterrestrial life. The implications are profound. We might not be alone in the universe, and the data gathered could redefine our place in it. Beyond the search for life, mapping galaxies would deepen our understanding of cosmic evolution. By studying the formation and interactions of galaxies over billions of years, we could piece together how the universe grew from a dense, hot soup of particles into the vast, intricate web we see today. This knowledge wouldn't just satisfy our curiosity, it could revolutionize fields like astrophysics and cosmology, providing a clearer picture of how everything fits together. The data collected could even help us predict the future of the universe, from the fate of individual stars to the ultimate destiny of the cosmos itself. Of course, with such groundbreaking discoveries comes significant ethical considerations. As we push the boundaries of space exploration with autonomous systems, we must ask ourselves, who gets to decide where we explore and how? What happens if we discover signs of life? Do we make contact or observe from a distance? These questions remind us that while the technology to map new galaxies is awe-inspiring, it also carries a responsibility to explore thoughtfully and ethically. As we venture further into the unknown, balancing our thirst for knowledge with respect for the universe's mysteries will be key to shaping a future where exploration and ethics go hand in hand. When we think about sending autonomous spacecraft to explore new galaxies, it's easy to get caught up in the excitement of discovery. But there's a deeper layer to consider. What are the ethical implications of venturing into uncharted territories? Picture this, a spacecraft powered by cutting-edge artificial intelligence travels light years away to a pristine, untouched galaxy. What happens if it inadvertently carries Earth-based microbes? Could we unintentionally contaminate an alien ecosystem before we even understand it? The stakes are high, and the responsibility falls squarely on humanity's shoulders. This isn't just about scientific curiosity, it's about stewardship. We're not just explorers, we're potential caretakers of the cosmos. The idea of colonizing distant galaxies might sound like science fiction, but it's a very real possibility. And with that possibility comes a moral obligation. Should we even attempt to colonize these worlds, or should we limit ourselves to observation and study? These questions aren't just for scientists and engineers to answer, they're for all of us to grapple with. To navigate these ethical dilemmas, international cooperation is crucial. Space exploration isn't the domain of a single nation. It's a shared human endeavor. Establishing ethical guidelines that transcend borders will be essential to ensure that our actions in space reflect our highest ideals. Imagine a global framework where nations work together to set standards for responsible exploration, rules that prioritize preservation over exploitation. It's a lofty goal, but one that's within reach if we commit to collaboration. And then there's the economic side of things. Autonomous space exploration isn't just a scientific or ethical pursuit, it's also a financial one. The resources required to build and launch these spacecraft are immense, and the potential returns, whether in the form of new knowledge, resources, or even habitable worlds, are equally vast. Balancing these economic incentives with ethical considerations will be one of the defining challenges of this new era of exploration. As we stand on the brink of this bold new frontier, one thing is clear: the decisions we make today will shape the legacy we leave for future generations, not just on Earth but across the cosmos. When we think about the economic feasibility of autonomous spacecraft, the first question that comes to mind is, how much does it really cost to map galaxies without human hands on the controls? The answer lies in understanding the trade-offs between upfront investment and long-term savings. Developing autonomous systems for space exploration isn't cheap. It requires cutting-edge artificial intelligence, advanced robotics, and a lot of testing to ensure these systems can operate flawlessly in the unforgiving environment of space. But here's the kicker: once these spacecraft are deployed, they can operate for years, even decades, without the need for constant human oversight. That's where the savings start to add up. Traditional space missions, like those involving crewed spacecraft or remotely operated probes, come with hefty price tags. Not only do you need to account for the salaries and training of astronauts or ground control teams, but you also have to factor in the cost of life support systems, communication networks, and the risks associated with human error. Autonomous spacecraft, on the other hand, eliminate many of these expenses. They don't need food, oxygen, or a return trip to Earth. They can work around the clock, making decisions in real time without waiting for signals from mission control millions of miles away. Over time, this efficiency translates into significant cost reductions, making galaxy mapping more accessible than ever before. But where does the funding for such ambitious projects come from? Historically, government agencies like NASA and the European Space Agency have been the primary drivers of space exploration. These organizations have the resources and expertise to tackle large-scale missions, and they're increasingly investing in autonomy as a way to stretch their budgets further. However, the landscape is changing. Private companies are stepping into the arena, bringing fresh ideas and a willingness to take risks that traditional agencies might shy away from. SpaceX, for example, has already revolutionized space travel with reusable rockets, and it's not hard to imagine them leading the charge in autonomous spacecraft development. International collaborations also play a crucial role. Space exploration is one of those rare fields where countries often set aside differences to work toward a common goal. By pooling resources and expertise, nations can share the financial burden and accelerate progress. This spirit of cooperation could be the key to unlocking the full potential of autonomous spacecraft, turning what might seem like a distant dream into a tangible reality. As we look ahead, it's clear that private companies will be at the forefront of this technological revolution. Their agility, innovation, and appetite for bold ideas are driving the development of autonomous systems faster than ever before. And with each breakthrough, the dream of mapping new galaxies becomes not just a scientific endeavor, but a financially viable one too. Private companies have become the engines of innovation in autonomous spacecraft technology, reshaping how we approach space exploration. Take SpaceX, for example, which has revolutionized reusable rocket technology, drastically lowering the cost of sending payloads into orbit. Their autonomous Dragon spacecraft, equipped with advanced AI, can dock with the International Space Station without human intervention. Blue Origin, on the other hand, is pushing the boundaries of propulsion systems, developing next-generation engines that promise greater efficiency and reliability for deep space missions. These companies aren't just chasing profit, they're solving some of the most complex challenges in space travel, from precision navigation to sustainable fuel solutions. But it's not just about individual achievements. Private firms are increasingly collaborating with government agencies like NASA and the European Space Agency, creating partnerships that amplify their impact. For instance, NASA's Commercial Crew Program relies on SpaceX and Boeing to transport astronauts to the ISS, blending public oversight with private sector agility. This synergy allows governments to focus on long-term scientific goals while companies handle the technical heavy lifting. It's a win-win for innovation and for humanity's ambitions in space. What's even more exciting is how these partnerships are paving the way for international collaboration. Space exploration is no longer confined to a single nation's efforts. Companies like SpaceX and Blue Origin are working with organizations across the globe, sharing knowledge and resources to tackle universal challenges. From monitoring climate change to preparing for missions to Mars, the combined expertise of private and public entities is accelerating progress in ways that wouldn't be possible otherwise. This spirit of cooperation is not just a trend, it's the foundation of our future in the cosmos. Space exploration has always been a frontier that transcends borders, and when it comes to mapping new galaxies, the stakes are too high for any single nation to tackle alone. The sheer scale of the universe demands a collective effort, bringing together the brightest minds, cutting-edge technology, and shared resources from across the globe. Think about it. Autonomous spacecraft designed to map distant galaxies require advancements in artificial intelligence, propulsion systems, and data analysis on a level that no single country can achieve in isolation. This is where international collaboration becomes not just beneficial but essential. One of the most iconic examples of this kind of teamwork is the International Space Station, or ISS. For over 2 decades, it has served as a shining example of what humanity can accomplish when nations unite for a common goal. The ISS is a product of collaboration between NASA, Roscosmos, ESA, JAXA, and CSA space agencies representing countries that, on Earth, might have differing priorities or even conflict. Yet, in orbit, they've created a shared home for scientific discovery. This kind of partnership sets a precedent for what could be achieved in the realm of autonomous spacecraft and galaxy mapping. By pooling expertise and resources, we can accelerate progress in ways that would be impossible if each country worked alone. But collaboration isn't without its challenges. Geopolitical tensions can complicate even the most promising partnerships. Disputes over funding, intellectual property rights, or even the direction of a mission can slow progress or derail projects entirely. For instance, who owns the data collected by an autonomous spacecraft funded by multiple nations? How do we ensure that the benefits of these discoveries are shared equitably? These are complex questions that require careful negotiation and trust building among nations. Yet, history has shown that when the stakes are high enough, humanity can rise above its differences. The IS, after all, was built during a time of significant geopolitical uncertainty, proving that cooperation is possible even under pressure. Looking ahead, the timeline for achieving Galaxy mapping through autonomous spacecraft hinges on our ability to sustain and expand these partnerships. Experts estimate that within the next 2 to 3 decades, we could see the first missions capable of mapping distant galaxies with unprecedented detail. But this timeline isn't fixed. It depends on how quickly we can overcome technical, financial, and political hurdles. By fostering global collaboration, we can shave years off this timeline, bringing us closer to unlocking the mysteries of the cosmos. The journey won't be easy, but the rewards expanding our understanding of the universe and our place within it are worth every effort. So, when could we realistically expect autonomous spacecraft to start mapping new galaxies? Let's break it down step by step. Right now, we're in the early stages of developing the technology needed for such missions. Prototypes of autonomous spacecraft are already being tested, but they're far from ready to venture into uncharted galactic territories. These early models are focused on mastering navigation and decision-making in environments closer to home, like our solar system. Think of it as training wheels for the grand cosmic journey ahead. The next big milestone, likely within the next 10 to 15 years, will involve deploying spacecraft capable of handling longer missions. These missions will serve as proving grounds, testing how well these systems can operate independently over vast distances and timescales. Key challenges include improving propulsion systems for faster travel, developing more efficient power sources to sustain the spacecraft, and refining the artificial intelligence that will allow these machines to make split-second decisions without human intervention. By this stage, we'll start seeing missions that explore nearby star systems, laying the groundwork for what's to come. Fast forward another decade or two, and we could see the first true autonomous galaxy mapping missions. These spacecraft would need to be equipped with advanced sensors and imaging systems to capture detailed data about distant galaxies. They'd also rely on breakthroughs in communication technology to relay their findings back to Earth across millions of light years. It's a monumental task, but one that builds on incremental advancements in robotics, AI, and space engineering. Each small step forward, whether it's a more efficient thruster or a smarter navigation algorithm, gets us closer to the ultimate goal. What's exciting is that we're not starting from scratch. Many of the technologies required for autonomous galaxy mapping are already in development, driven by both government space agencies and private companies. For example, NASA Artemis program is pushing the boundaries of deep space exploration, while initiatives like SpaceX's Starship are redefining what's possible in terms of spacecraft design and reusability. These efforts, combined with international collaboration, create a foundation for the ambitious missions of the future. But let's not forget the human element. While the spacecraft will be autonomous, their success will depend on the ingenuity and perseverance of the scientists and engineers working tirelessly behind the scenes. Every breakthrough, every milestone, is a testament to our collective curiosity and determination to explore the unknown. And as we look ahead, it's clear that the future of space exploration will be shaped not just by the machines we build, but by the vision and creativity of those who dare to dream big. Picture a future where the night sky isn't just a canvas of distant stars, but a map waiting to be explored, a map charted by autonomous spacecraft venturing into the unknown. These self-guided explorers, equipped with cutting-edge AI and advanced propulsion systems, could one day become the backbone of interstellar travel, uncovering the secrets of galaxies far beyond our own. Imagine a fleet of these spacecraft, not just observing but actively mapping uncharted territories, identifying habitable planets, and laying the groundwork for humanity's next great leap, colonization of distant worlds. This isn't just science fiction, it's a vision of what's possible when technology and ambition collide. The potential for interstellar travel is staggering. With autonomous spacecraft, we could send missions to star systems that are currently out of reach, studying their planets for signs of life, resources, or even future homes for humanity. Think about it, a spacecraft that can navigate the vast emptiness of space, make decisions on its own, and adapt to unforeseen challenges without waiting for instructions from Earth. This level of autonomy would drastically reduce the time it takes to explore and understand the cosmos, opening doors to discoveries we can barely imagine today. But beyond the technical marvels, there's something deeply inspiring about this vision. Imagine the ripple effect it could have on future generations. Young minds watching these spacecraft embark on their journeys might be inspired to dream bigger, to pursue careers in science, engineering, or exploration. It's not just about the discoveries themselves, it's about the spark of curiosity and wonder that these missions could ignite in people around the world. The idea of exploring new galaxies could become a shared human aspiration, uniting us in our quest to understand the universe. And then there's the societal impact. Autonomous spacecraft could reshape how we see ourselves in the grand scheme of things. By pushing the boundaries of what's possible, these missions could challenge us to think differently about our place in the cosmos. They might even force us to confront questions about sustainability, cooperation, and the ethical implications of colonizing other worlds. After all, if we're capable of sending machines to map galaxies, what does that say about our potential as a species? It's a reminder that our future isn't just tied to Earth, it's written in the stars. This vision of the future isn't just about technology, it's about hope, ambition, and the unrelenting drive to explore. Autonomous spacecraft could be the key to unlocking a new era of discovery, one that reshapes our understanding of the universe and our role within it. And as we look to the stars, we're reminded that the journey is just as important as the destination. Picture a world where autonomous spacecraft have unlocked the mysteries of distant galaxies, not just for scientists but for everyone. The societal impact of this technology goes far beyond the stars. It reshapes how we see ourselves, our potential, and our place in the universe. These spacecraft could ignite a renewed passion for science, inspiring generations to look up at the night sky with wonder and curiosity. Imagine a child gazing through a telescope, dreaming of the day they might help map a new galaxy or uncover the secrets of an alien world. This isn't just about exploration, it's about awakening a collective sense of possibility. But the ripple effects don't stop there. The development of autonomous spacecraft could spark a wave of technological innovation, much like the space race of the 20th century. Think of the countless advancements that emerged from the Apollo program, everything from satellite technology to medical imaging. Autonomous spacecraft could drive similar breakthroughs, pushing the boundaries of robotics, artificial intelligence, and materials science. And with these advancements come new industries and job opportunities, from designing and building spacecraft to analyzing the vast amounts of data they collect. The economic potential is staggering, offering a new frontier for entrepreneurs and engineers alike. Culturally, the discovery of new galaxies, or even the faintest hints of extraterrestrial life, could redefine how we understand our existence. Imagine the moment humanity receives confirmation that we're not alone in the cosmos. That realization would ripple through art, literature, and philosophy, challenging us to rethink our beliefs and values. It's a moment that could unite us, reminding us of our shared humanity in the face of the infinite. And yet, this journey into the unknown also raises profound philosophical questions. What does it mean to map the cosmos? Are we seeking to conquer it, to understand it, or simply to find our place within it? As we send these autonomous explorers deeper into space, we're not just charting stars, we're exploring the very essence of what it means to be human. This isn't just a scientific endeavor, it's a quest for meaning that has the power to transform society in ways we can't yet fully comprehend. Mapping new galaxies isn't just a scientific endeavor, it's a journey that challenges the very way we see ourselves in the cosmos. For centuries, humanity has looked up at the stars and wondered, are we alone? What does it mean to exist in such an unfathomably vast universe? The discovery of other galaxies and the possibility of encountering extraterrestrial civilizations could fundamentally shift our perspective. It forces us to confront questions about our significance, our purpose, and our connection to something far greater than our own planet. Imagine a future where we've charted countless galaxies, each one teeming with its own mysteries. What if we found evidence of life or even intelligence beyond Earth? Such a discovery wouldn't just expand our scientific knowledge, it would redefine what it means to be human. Suddenly, our story isn't confined to this pale blue dot. We become part of a larger narrative, one that spans billions of light years and untold eons. This realization could inspire a profound sense of unity, reminding us that we're all passengers on the same cosmic voyage, regardless of borders or beliefs. At the same time, space exploration has a unique way of grounding us. As we reach for the stars, we're reminded of the fragility of our own world. The same technology that propels autonomous spacecraft across galaxies also highlights the need to protect our planet. Every mission, every discovery underscores the importance of sustainable innovation. After all, if we can navigate the complexities of interstellar travel, surely we can address the environmental challenges here at home. This duality of looking outward while reflecting inward is what makes space exploration so compelling. It's not just about the technology or the discoveries, it's about what those discoveries reveal about us. And as we continue to map the cosmos, we're not just charting stars, we're charting our own future, one that balances curiosity with responsibility. As we marvel at the incredible potential of autonomous spacecraft to map new galaxies, it's crucial to pause and consider the environmental footprint of these missions. Space exploration, while groundbreaking, isn't without its challenges, especially when it comes to sustainability. Every rocket launch, for instance, releases significant amounts of greenhouse gases and other pollutants into the atmosphere. This raises an important question. How can we balance our quest to explore the cosmos with our responsibility to protect our own planet? Efforts are already underway to make space exploration more eco-friendly. Scientists and engineers are developing cleaner propulsion systems, such as electric and solar-powered engines, which reduce reliance on traditional chemical fuels. These innovations not only lower emissions but also pave the way for longer, more efficient missions. Additionally, there's a growing focus on creating spacecraft that are fully recyclable or biodegradable, ensuring that they don't contribute to the growing problem of space debris. Speaking of space debris, this is another critical environmental concern. Thousands of defunct satellites, spent rocket stages, and other fragments are currently orbiting Earth, posing risks to both active spacecraft and future missions. To combat this, organizations like the European Space Agency are pioneering initiatives to clean up orbital clutter. Autonomous spacecraft could play a key role here, using advanced sensors and AI to track and remove debris, effectively turning them into cosmic janitors. But sustainability isn't just about technology, it's also about governance. As we push the boundaries of space exploration, there's an urgent need for clear legal frameworks to ensure that these activities are conducted responsibly. International treaties such as the Outer Space Treaty already provide a foundation, but they were drafted long before autonomous spacecraft became a reality. Today, we need updated regulations that address issues like space traffic management, debris mitigation, and the ethical use of AI in space. By combining innovative technology with thoughtful policy, we can ensure that our journey into the stars doesn't come at the expense of our planet or the cosmos itself. The future of autonomous spacecraft isn't just about discovery. It's about doing so in a way that respects the environment and sets a sustainable precedent for generations to come. As we venture deeper into the possibilities of autonomous spacecraft mapping new galaxies, one critical aspect often overlooked is the legal framework governing such ambitious endeavors. Space, after all, is not a lawless frontier. It's a domain bound by international agreements and treaties designed to ensure peaceful and equitable exploration. The cornerstone of this legal structure is the Outer Space Treaty, signed back in 1967. This treaty, ratified by over 100 countries, establishes that space exploration should benefit all humankind and prohibits any nation from claiming sovereignty over celestial bodies. But here's the catch. This treaty was crafted in an era when human astronauts were the primary focus, not autonomous systems capable of making decisions without direct human intervention. This raises a fascinating question. How do we adapt these decades-old laws to accommodate the rapid advancements in artificial intelligence and robotics? Autonomous spacecraft, by their very nature, operate with a level of independence that challenges traditional notions of accountability. If an autonomous probe accidentally damages a satellite or alters an asteroid's trajectory, who bears the responsibility? The engineers who designed it, the organization that launched it, or the AI itself? These are the kinds of questions that current space law simply isn't equipped to answer. And as we push further into the cosmos, the need for updated regulations becomes increasingly urgent. We're entering a new era of exploration, and our legal frameworks must evolve to keep pace. But it's not just about laws and treaties, it's also about public engagement. Space exploration has always been a collective endeavor, fueled by humanity's shared curiosity and desire to understand the universe. As we develop autonomous systems capable of mapping galaxies, it's crucial that the public remains an active participant in this journey. After all, space exploration isn't just for scientists and engineers, it's for everyone. Public support and awareness can drive funding, influence policy, and even shape the ethical standards we apply to these technologies. By fostering a sense of ownership and connection, we can ensure that the benefits of autonomous space exploration are truly universal. This brings us to an important realization. The future of space exploration isn't just about technology, it's about collaboration. Collaboration between nations, between scientists and policymakers, and between the experts and the everyday people who look up at the stars and wonder what's out there. As we navigate the legal and ethical challenges of autonomous spacecraft, one thing is clear. The journey to map new galaxies is as much about building bridges here on Earth as it is about reaching into the cosmos. Mapping new galaxies isn't just a task for scientists and engineers. It's a journey that belongs to all of us. Public engagement plays a crucial role in making these missions possible. When people feel connected to the wonders of space, they become advocates, supporters, and even contributors to the cause. One of the most exciting ways this happens is through citizen science projects. These initiatives invite everyday people to participate in real scientific research, whether it's by analyzing telescope data, identifying celestial objects, or even helping to spot anomalies in deep space imagery. Imagine being part of a global team that helps uncover the mysteries of the cosmos. It's an opportunity that's both empowering and inspiring, but it doesn't stop there. Educational programs are another key piece of the puzzle. By introducing students and the general public to the science behind space exploration, we're planting seeds for the next generation of astronomers, engineers, and dreamers. Schools, museums, and online platforms are increasingly offering interactive experiences that make complex concepts accessible and exciting. Think about it. A child today who learns about the Andromeda Galaxy through a virtual reality simulation might grow up to design the spacecraft that maps it in unprecedented detail. Public interest doesn't just fuel curiosity, it drives action. When people are captivated by the stories of distant stars and galaxies, they're more likely to support funding for space missions. Whether it's through advocacy, donations, or simply sharing the excitement with others, the collective enthusiasm of the public can make a tangible difference. Space agencies and private organizations alike recognize this, which is why many of them are investing in outreach programs that bridge the gap between science and society. As we look to the future, the relationship between public engagement and space exploration will only grow stronger. The more we share the wonders of the universe, the more we inspire people to dream big and reach for the stars. And that's what makes missions to map new galaxies not just a scientific endeavor, but a shared human adventure. As we bring this exploration to a close, it's impossible not to marvel at the sheer scale of what autonomous spacecraft could achieve in our quest to map new galaxies. These self-guided marvels of engineering are poised to revolutionize our understanding of the universe, venturing into the farthest reaches of space where no human has gone before. By combining cutting-edge artificial intelligence with advanced propulsion systems, they can navigate cosmic challenges, collect invaluable data, and beam back insights that could reshape our place in the cosmos. But this journey isn't just about technology, it's about humanity's relentless drive to explore, to push boundaries, and to answer questions that have lingered for centuries. The implications are profound. On a technological level, these missions could unlock breakthroughs in AI, robotics, and energy efficiency that ripple across industries here on Earth. Ethically, they challenge us to consider our responsibilities as cosmic explorers, ensuring that our pursuit of knowledge respects the integrity of the universe and any potential life we might encounter. And societally, they inspire us to dream bigger, to unite around a shared vision of discovery, and to invest in a future where the stars are no longer out of reach. So, what's next? The possibilities are as vast as the cosmos itself. Imagine a future where autonomous spacecraft map galaxies in real time, where we uncover the secrets of dark matter, or even stumble upon signs of extraterrestrial civilizations. These missions could redefine what it means to be human, connecting us to a universe that's far grander than we've ever imagined. Here's where you come in. Stay curious. Support the scientists, engineers, and visionaries working tirelessly to make these breakthroughs a reality. Share your enthusiasm for space exploration with others, and advocate for the resources and funding needed to propel these missions forward. Together, we can ensure that humanity's journey into the cosmos continues, not just for us, but for generations to come. As we look to the stars, remember this: the universe is vast, mysterious, and full of wonders waiting to be discovered. Let's embrace the adventure, fuel our collective curiosity, and dare to dream of a future where the galaxies are no longer uncharted territory, but destinations we've begun to understand. The next chapter of cosmic exploration starts now, and it's a story we're all a part of. If you've enjoyed this journey into the possibilities of autonomous spacecraft mapping new galaxies, don't forget to hit that like button and share this video with anyone who's fascinated by the wonders of space and technology. Your support helps us create more content that explores the cutting edge of what's possible. Make sure to subscribe to the channel so you don't miss out on future videos diving into the latest breakthroughs in space exploration, futuristic tech, and the mysteries of the cosmos. We've got so much more to uncover together, and your curiosity is what drives us forward. And hey, we'd love to hear from you. Drop a comment below with your thoughts, questions, or even your own ideas about how autonomous spacecraft could shape the future of space exploration. What excites you most about mapping new galaxies? Let's start a conversation. For those eager to dive deeper, check out the links in the description for related videos and resources that explore even more about the incredible advancements in space technology. There's a whole universe of knowledge waiting for you. To leave you with a final thought, here's a quote from Carl Sagan. "Somewhere, something incredible is waiting to be known." The universe is vast, mysterious, and full of endless possibilities. Who knows what we'll discover next? Thanks for watching, and we'll see you in the next adventure.